An idea about the small particles than the atom. The physicians, the physics, they have the table of the particles of the atom. They call it the standard model. 100 years and they make this table. How you have the periodic table of the elements. The physics, they have this table. These are the quarks that make this they are made from, the protons are made from quarks. And these are the group of electrons, which are this. And these, we will speak about them, the four forces. The four forces. You know all of the photon forces, the electromagnetic force. There is four kinds of forces. You know the gamma ray, ultraviolet, infrared, radio wave, gamma ray, X-ray. They are this force only. There are 3 other kinds of forces we will speak about. And you discovered the Higgs boson. They tell it's God particle, the scientists tell. We will speak about this. After we have proven and we finish our proofs, we will make our claim. I will tell the angels are made from this particle. And this particle, it's got to do with spirits. This is not proof, our claim. We will show our proofs, you will be the judge. Look, this is one of the Z bosons, one of the forces. It decays to neutrino and antineutrino. You know what is this? Let me show you again. Yani, one of the four forces, for example, the Z boson, they have proved it, like the light, is made from this neutrino. That the light even made smaller particles, this tau neutrino. I told you we will study, we will speak about this. They didn't prove this, but they are in the same group. They have proved that the Z boson, when it disintegrates, it makes tau neutrino. This is a big subject, we will speak about this. The light is made from this. They haven't proved it, we will make our claims. But they have proved that the Z boson are made of these neutrinos. Okay, just to give you an idea. Now we will look what it's telling here, very strange. He created all pairs, male and female. What the earth grows from plants, from your cells, and we are male and female, وَمِمَّا لَا يَعْلَمُونَ, and from things you do not know. Even this he made male and female. Even things we don't know, he made them male and female. Okay. Now we will, the last video about pair and male and female, there is even antimatter, just to show you. There is antimatter.
Positively charged antiproton and a positively charged positron. This evil antimatter twin version has the same mass, by the way. Experiments with antimatter in the journal Nature from November 2015 found that antimatter behaves exactly like matter, which is actually confusing. Shouldn't the opposite particle behave, I don't know, oppositely? More research is needed. The base rule of old physics is matter cannot be created or destroyed, but sorry, old physics textbook, that is not strictly speaking true. And in fact, when an electron hits a positron, they will annihilate one another, turning into energy in the form of gamma rays. Specifically, gamma rays at 511 kiloelectron volts. To scale that up, if 1 kilo of antimatter hit a kilo of matter, based on E equals mc squared, the resulting explosion would be 3,000 times the Hiroshima bomb. So, new physics, energy cannot be created or destroyed, because matter and energy are the same. This is like the principle of Star Trek's replicators and their transporters, Earl Grey, hot! But this annihilation is a big clue as to where antimatter went. We know this annihilation happens because of particle accelerators. When high-energy particles are smashed together or they naturally go through beta decay, tiny bits of antimatter are just created. Scientists clearly want to study this, but they need to hold on to those atoms of antimatter. And therein lies the rub. Our universe is full of matter. Whenever scientists create a particle of antimatter, it hits the mattery walls of the container and will instantly annihilate itself. How frustrating would that be? There's literally no way to hold antimatter in place, or there wasn't until now. In 2002, the Alpha Collaboration team at CERN announced that they'd trapped 38 anti-hydrogen atoms for 100...
There is proof now. They have made antimatter. They collected, they make antimatter, and they have proved it. Just I'm showing you so that you see the proof. There is antimatter. For example, if the proton is positive charge, there is proton negative charge. And if there is electron negative charge, there is electron positive charge. Different kind of matter. They have proved this. I'm showing you just to...
172 milliseconds each. There was a breakthrough at the time, but that's not a lot of stuff, or for a very long time. Then, in 2010, scientists trapped hundreds of antimatter atoms for more than 15 minutes, giving them time to explore how these mysterious things work. With this study, published in Nature Physics, as a base, cosmologists believe the Big Bang somehow created more matter than it did antimatter. Not a lot more, mind you, but more. A piece in The Guardian describes it as an infinitesimally small excess. Then, in the seconds after the Big Bang, all the matter and antimatter annihilated each other in huge amounts of energy, leaving behind just matter.
Okay. Now, we will speak about the atom again.
Quarks, which come in flavors like up and down, but they also come in colors.
We will speak about this so that you remember when we speak about the forces, the four forces. We told you atom is made proton and neutron and electron. And the proton is made of quarks, electrons. This is the normal atom, normal matter. Okay? This we know. You know something else than matter? This is it. The proton, neutron, electron. The proton are made of 3 quarks and the neutron also. This is it. And the exchange forces between the quarks are different kind of forces. We will speak about this. What is the force that holding the quarks together?
To build a particle, it has to be color neutral. So you either need 3 quarks that are red, green, and blue. Those particles are called baryons, and a proton is one of them. Or a meson is made with a quark and antiquark that are opposite colors combined, like red and what's the opposite of red?
Anti-red?
You are so literal. I love it. You're also completely correct.
Separate from quarks.
Okay, now we will speak more smaller than the quarks. We knew that quarks, they have antiparticle and the electron has antiparticle. We will speak about the forces. What do the forces, how they are? They have antiparticles. We know only the electromagnetic force. This is the exciting part.
Pretty good. Now, consider a piece of matter, and imagine taking it apart down to its basic constituents, the particles that make it up, down to the atoms, and further down to the protons, neutrons, and finally to the quarks and electrons. If our hands are small enough, we can hold...
How does the electron know the proton is there? And what draws it towards the proton? How does the electron know not to be attracted to the neutron? The answer is that the electron...
Look, this is the electron outside the atom. This is the proton. How they are holding together? With the force of the electromagnetic waves. This is the force. Because this is positive and this is negative. This is the electromagnetic force that we know. Positive and negative. The force that we know, it works on this principle. Positive and negative.
And the proton each fill the space around them with countless millions of other tiny particles that have only the most ephemeral existence. Because it is electrically neutral, the neutron does not.
This is the four forces. This is the electromagnetic force, you know about it. We will speak about the rest.
Gauge bosons can exist for a longer time, and these in turn can get further from the parent before they must return. So the range of a force is directly related to the mass of its gauge boson.
I will speak about you. The force that you know, positive and negative light, ultraviolet, or this light, it's made of particles called photons. They call this particle photons. We will see the rest of the force what are made of.
Proton is a gauge boson for the electromagnetic force, and the graviton is the gauge part.
And the graviton particle for gravity, you notice the graviton, the force.
For gravity. Both of these particles are massless. And so the range of these two forces, strong force, is much more complex.
This is the strangest force, the strong force. This force, it doesn't work at positive and negative. It works with colors. It has 3 colors, 3 charges, not the 2 charges that we know, positive and negative. It has 3 charges. It's a strange force.
The charge property responsible for the force between quarks comes in the...
This is the force that holds the protons inside them, the quarks, together. If there isn't the strong force, the quarks, the atom, they don't make matter. Because the positive, negative electromagnetic force, size small of an atom, it cannot hold the atom. This strange, strong force, it has 3 kinds of charges. This is the force, and its particle, it's not made of photon like the electromagnetic force that we know. It's made of a particle, it's called gluon, like a glue. It holds the atom together.
3 distinct states. Not just 2, like the positive and negative charge states in electromagnetism. So in a loose analogy to the 3 primary colors, red, green, and blue, the 3 kinds of charges in a strong force are usually referred to as color charge, and are designated red, green, and blue. An exchange of gluon.
Look, the proton, it's made of 3 quarks, and the forces inside the strong force, they always exchange gluon particle together so that they hold together. This is the atom.
They swap colors. Also, because gluons are attracted to each other, it is possible to have a gluon collection, which is referred to as, what else, a glue bond. The interactions that result from the weak force.
This is another force. We didn't speak too much about the strong force. It's a big subject. We speak about the weak force. The weak force causes radiation in the metals, okay?
Are incredibly short-ranging. They're effective over a distance even smaller than a proton's diameter. The standard model of physics combines QCD with
This is the standard model about physics we talked about.
QED and the weak force theory. It states that there are 6 quarks and 6 leptons.
Okay, we remind you again. The atoms are made of quarks and leptons, the electrons, and the 4 forces. The 4 forces, the strong force, are made of gluons. The electromagnetic force from photon, and the weak force, Z boson.
And 12 gauge bosons, as well as their antiparticles.
Look, even they have the antiparticle. Now we proved our point. Even the forces, they have antiparticle.
Only the up and down quarks, the electron, and the lightest neutrino are populous today. In the standard model, the entire system of matter and forces, except gravity, is encapsulated in few simple equations, and is organized around one core principle, known as local gauge symmetry. Amazing.
Okay,